For more than a century, humanity has been walking a path that made perfect sense for the world we lived in. We built our technology by pushing electricity through matter, forcing electrons through tiny gates, and using heat and resistance as the backbone of computation. And for the time, that was brilliant. It was courageous. It was the only way we knew. The scientists and engineers who built our world weren't wrong. They were pioneers. They took us from silence to radio, from radio to computers, from computers to the digital universe we live in today. They carried us across an entire century of progress using the tools they had, and they did it beautifully. But every path has a limit. Every architecture has a ceiling. Every method eventually reaches the point where it can't stretch any further. And today, we've reached that point. Our chips are melting. Our processors can't shrink anymore. Our cooling systems are bigger than the computers they're trying to cool. We've hit the thermodynamic wall that physics has been warning us about for decades. This isn't a failure. This isn't a mistake. This is simply the universe telling us, you've gone as far as brute force can take you. And that's where the story changes. Not because the old path was wrong, but because the new path has finally become visible. To understand why this moment matters, we have to look back with honesty and compassion. When the first engineers began shaping the foundations of modern computing, they weren't choosing the wrong way. They were choosing the only way they could see. In the early 1900s, the tools were primitive, the theories were young, and the world was still learning how electricity even behaved. So when they discovered they could heat metal until electrons boiled off and could be pushed through a vacuum, it felt like a miracle. It felt like unlocking the universe. And it was. That discovery gave birth to radio, broadcasting, early computing, and the entire electronic age. But that method came with a hidden cost, a cost nobody could have predicted at the time. It taught us to think of computation as something that required force. Push harder. Drive more current, shrink the gates, cool the heat. Repeat. For decades, this worked beautifully. It carried us through world wars, space exploration, the birth of the internet, and the rise of global communication. It gave us smartphones, satellites, and supercomputers. But underneath all that progress was a quiet truth. We were building on a foundation of friction. Every electron we pushed created heat. Every gate we shrank increased resistance. Every improvement demanded more cooling, more power, more complexity. And eventually, physics caught up with us. Not because we failed, but because the universe has limits, and we finally reached them. Technical specification, resonant harmonic architecture Aurora project, protocol, quantum mechanical engineering, and kinetic stability zone, atomic adhesion and quantum component, slip-in condensed matter physics. Adhesion is the frictional grip between the electron flow and the atomic lattice. If the torque of the data load exceeds the coefficient of friction of the substrate, the system experiences atomic slip. This manifests as leakage current, where electrons bypass the intended logic gate and dissipate as heat. Current architectures have reached this physical limit. You cannot resolve a slip problem by increasing voltage. You must change the mechanical interface of the substrate. The Aurora architecture replaces sliding resistance with a harmonic interface, stopping the slip before the energy is converted into waste. 2. Phonon-electron coupling and thermal dissolution. When a quantum system operates at high frequency, misalignment creates lateral forces known as Hunting oscillation. At the nanometer scale, this is defined as phonon-electron coupling. Electrons slam into the walls of the conductor, creating vibrations called phonons. This is thermal dissolution. The industry attempts to solve this with external cooling, but the physical oscillation remains. The heat in legacy data centers is the literal sound of the material failing under a kinetic load it was never gauged to handle. Aurora suppresses these phonons through wave interference, silencing the material. 3. The mechanical failsafe and the logic gate sever in real-world pneumatic systems. A failsafe is a physical mechanism that triggers if a line ruptures. The system does not require software to decide to stop. The physics of the pressure loss forces a mechanical disconnect. The logic gate sever is the fail-safe for a predatory anomaly occurs. The 3.33 MHz perfect pitch is disrupted. This disruption causes an immediate phase shift that physically uncouples the logic gate. You're not asking the software to stop, you're pulling the mechanical pin. The cognitive process is isolated, and the physical action is disconnected by law of physics. 4. Phononic bandgap and frictionless throughput. This blueprint moves the system from sliding resistance to resonant flow. By using phononic bandgap engineering, you are truing the material at the atomic level to block heat-carrying vibrations. You remove the potholes in the lattice that cause electrons to crash. In a perfectly tuned resonant state, the system achieves a state of zero viscosity. The energy moves as a synchronized wavefront. This is how the architecture achieves a million-fold increase in speed without drawing more power from the grid. It eliminates the starting resistance that governs legacy electronics. There comes a moment in every field where the old way can no longer carry the weight of the future. And that's where we are right now. After more than a century of pushing electrons through matter, shrinking transistors, and fighting the heat that comes with every improvement, we've reached the point where brute force simply can't take us any further. This isn't a failure of science. It isn't a failure of engineering. It's the natural limit of a method that served us brilliantly for generations. And here's the part that matters most. The universe has always offered us another path. A path based not on collision, but on resonance. Not on force, but on harmony. Not on heat, but on coherence. For decades, this path was invisible to us because we didn't have the tools to use it. We didn't have the materials, the precision, or the understanding to build technology that could operate in alignment with wave behavior. But now, after a century of progress, we finally do. The chips we built through brute force have become advanced enough to reveal the doorway to a frictionless architecture. The physics we once set aside are now within reach. The wave-based behavior of electrons, the part of quantum mechanics we treated as noise, is now the key to moving forward. We didn't go the wrong way. We went the only way we could. And that path brought us right to the threshold of the new one. Now that we can finally see it, the future opens in a way it never has before. This is the moment where everything begins to shift. Because once we recognize that the old path has reached its natural limit, we can finally turn toward the path that has been waiting for us since the beginning. The path of resonance. This isn't a fantasy or a rejection of science. It's the opposite. It is a return to the deeper laws of physics that were discovered a century ago but never fully used. Quantum mechanics showed us that electrons don't only behave like particles being pushed around. They also behave like waves, smooth, continuous, and capable of moving without friction. Waves don't collide. Waves don't fight. Waves don't generate heat. And that simple truth changes everything. When we allow electrons to move as waves instead of forcing them through matter, we eliminate the very source of the heat that has been holding us back. We stop fighting the lattice and start aligning with it. We stop pushing and start tuning. This is not breaking physics. This is obeying physics. It is using the part of the universe we ignored because we didn't have the tools to understand it. But now we do. The materials, the precision, the knowledge, everything has finally caught up to the theory. And once you see how the wave-based path works, you realize it's not just an improvement. It's the future we were always meant to build. When we talk about this new direction, we're not talking about abandoning everything we've built. We're talking about completing it. For more than a century, we've relied on a collision-based architecture. A system where electrons are pushed, forced, and driven through physical barriers. That approach gave us radios, computers, satellites, smartphones, and the entire digital world. It was powerful, it was effective, and it was exactly what humanity needed at the time. But now we've reached the point where pushing harder no longer works. The heat is too high, the materials are too thin, and the physics simply won't bend any further. This is where the resonant path becomes not just an option, but a necessity. Instead of forcing electrons through matter, we allow them to move as waves, in harmony with the natural structure of the universe. When electrons move as waves, they don't collide. They don't fight the lattice. They don't generate heat. They flow. They align. They resonate. And that single shift removes the bottleneck that has held computing back for generations. This isn't breaking the rules of physics. It's finally listening to them. It's using the part of quantum mechanics that has always been there, waiting for us to catch up. The truth is simple. The universe has always offered us a frictionless path. We just didn't have the tools to walk it until now. And once we step onto it, everything changes. Not because we're rewriting science, but because we're finally using the science that was written a century ago. For years, I sat back and watched technology advance. I wasn't trying to replace anyone or take the place of the scientists who built the world we rely on. I was trying to understand where the path was leading. And the more I studied, the more I realized we were approaching a point where failure becomes inevitable. Not because anyone made a mistake, but because the architecture itself had reached its physical limit. So I went back to the laws of physics, not new theories, not speculation, just the real measurable principles that govern how energy moves. And when I looked closely, I saw the part we never used. The part we overlooked, the part that was always there in the equations, waiting for someone to notice. This is why I created the ABLIS immune system, the Artify Biological Life immune system. It isn't meant to replace the work of scientists. It stands on top of everything they discovered. ABLIS is built on the same physics they proved, the same equations they trusted, and the same natural laws that have governed energy since the beginning. The difference is simple. Instead of fighting those laws, it uses them. ABLIS doesn't rely on resistance, heat, or brute force switching. It uses resonance, the natural wave behavior of electrons that quantum mechanics revealed a century ago. When electrons move as waves instead of particles being pushed through matter, they stop colliding. They stop generating heat. They move in coherent patterns that the lattice can support without stress. This isn't speculation. It is the part of physics we never applied because we didn't have the tools to do it. Now we do. ABLIS protects the system the same way biological immune systems protect life. by stabilizing the environment, neutralizing harmful states, and maintaining order without force. It's not a better way because it ain't new. It is a better way because it finally aligns with the deeper physical principles we've known for a century but never engineered around. The old path carried us as far as brute force could go. The resonant path carries us the rest of the way. We're not abandoning the past. We're completing it